This video discusses queries, what they are and how to create them. Queries are crucial in database operations. As discussed in the companion video, Introduction to Relational Databases, large amounts of data are typically stored in related tables of a database package, where the relationships are defined through primary and foreign keys. These tables are purposely kept separate to avoid redundancy. However, users can then ask for data from these tables by using queries. A typical query might be, find the total amount spent on each product in the seafood department in each of the California stores during April of this year. A typical query such as this one requires information from several tables, so these tables must be joined, at least temporarily, to provide the requested information. As this example suggests, a query requires at least two pieces of information: a list of the tables that contain the requested data, and a list of the fields in these tables that are of interest. Many queries also required a third piece of information, the specification of filters, such as restricting the customer state to California or the product category to be seafood. They might also specify a sort order, such as sorting and decreasing order of total amount spent. Conceptually, you can think of a query being performed as follows. First, the tables that contain the requested data are joined into one large table. Then the list of requested fields determines the columns of this table to return, and the filters determine the rows to return. The exact details of how the database package does this are not important for our purposes. All you have to understand is that the query returns a table of the results you want. And more importantly for this course, this resulting table, which might still be huge, can be the basis for a pivot table. You should also understand how to specify a query. This is typically accomplished by one of two methods. First, many database packages have a graphical user interface. This allows you to choose the tables to include, the fields to include, the criteria for filters, and optionally a sort order. Microsoft's Access software is typical, as you see here. For illustration, I will use the famous Northwind database that has been included for demos in Access for years. Among other things, it contains the tables you see here, along with the relationships diagram for showing the relationships between the tables. It also contains a number of saved queries. It is important to realize that these queries store only the questions to be answered, that is, the query specification. They don't store the results of the query. These results aren't found until you run a query. Of course, this provides a dramatic savings in storage space. Only the data in the tables need to be stored. The query results can be found when they are needed. To see one of these queries, I will look at Design View, the graphical user interface. For example, here is the product sales for 1997 query in Design View. It requires data from four tables: categories, products, order details, and orders. These tables are listed in the top pane. The bottom pane lists the requested fields, those with a check mark, and the criteria line shows any requested filters. In this case, there is only one. The ship date must be in 1997. There is one other feature of this query which is quite common. There is a calculated field, product sales, created by the formula in its column. And this calculation is grouped by category name, product name, and the quarter in the ship date. In words, a total of product sales will be listed for each product in each category and each quarter. I will now run this query to show the results. As you can see, the result is a table with exactly the information requested. Access isn't the only software package with a graphical user interface for specifying queries. There are plenty of them. Each works similarly, but the details, especially for complex queries, can be difficult to master. Therefore, there is a second way to specify queries that is common to all database packages. This is the so-called language of databases, structured query language, or SQL. Some people pronounce this SQL and others pronounce it SQL. This language has been around for several decades, and it is essentially the same for all relational database packages, although there are a few differences across packages. If you plan to do much work with databases, you will need to learn SQL. Fortunately, it isn't a very difficult language to learn. Here is the SQL statement for a simple query, the current product list query. This is a single command, even though it is broken over several lines, or clauses. The keywords are capitalized. The select clause lists the fields to return. The from clause lists the tables used. The where clause specifies the filters, and the order by clause specifies the sort order. The select and from clauses are required, the others are optional. Here is the SQL statement for a more complex query, the product sales for 1997 query. Admittedly, this looks horribly complex, but it isn't really that bad if you pick it apart. In particular, notice the inner joins in the from clause. These specify how to join the related tables through their primary and foreign keys. This is enough for now. You could take a whole course on creating queries in Access or any other database package, or how to write SQL statements. This is not our purpose. The main point here is that you can base a pivot table on the result of a query, regardless of how this query is created and which database package it comes from.